So again, this is chapter 1.1, and it's about place value and patterns, okay? And our learning goal today is that by the end of math today, we will be able to recognize the relationship among place value positions. Okay, so let's do a quick review of place value, okay? So let's look at number 1. Oh, hold on one second. So on page 3 of your book, you're going to see these exact same problems, right? All I did was take a picture from your book so that we can talk about it. So you'll see number 1, you see a number there. And all of the digits are written out. So I want us to review and see if we can think of or figure out what is the value of each digit in the given number. So number 1, what is the value of that 2? What is the value of that 2, Joseph?
2,000.
2,000. Okay, go ahead and write that in. Yep, in the book. This is your book to write on. Okay, what's the value of the 9? What's the value of the 9, Liam?
900.
900. Go ahead and write that in. What's the value of the 0? What's the value of the 0? Karan? 0. And finally, what's the value of the 4? Adam? 4. Good. Okay, let's look at number 2. What's the value of the 6 in this number? What's the value of the 6? Adriana?
6,000.
6,000. Go ahead and write that in. What's the value of the 4? Harshita?
400.
400. Okay. What's the value of the 2? Ariel? 20. And what's the value of the 3? Neha?
3.
Good. Okay. It says you can use space 10 blocks like these to understand the relationships among place value positions. Use a large cube for how much? 1,000. A flat for 100. A long for
10.
and a small cube for
1.
Okay, so let's look at problem A. It says complete the comparisons below to describe the relationship from one place value position to the next place value position. So how many of the small cubes would it take to make one long? How many?
10.
Oh, I love the way Tomby showed me with her fingers. 10. So then it says the long is 10 times as much as the small cube. Let's go ahead and write that in. The long is therefore 10 times as much as the small cube. Okay, now let's compare the flat and the long. How many longs would it take to make the flat? How many longs would it take to make the flat? Arushi?
10.
10. So therefore we know that the flat is how many times as much as the long? 10. Okay, the flat is 10 times as much as the long. Okay, now let's look at the large cube and compare it to the flat. How many flats would it take to make the large cube, Siddharth?
10.
So therefore we know that the large cube is how many times as much as the flat? 10. Okay, very good. Go ahead and write that in. Let's look at the flat, okay, and compare it to the large cube. If we know it takes 10 of the flats to make one large cube, how do we compare the flat to the large cube? Which one's bigger, first of all? Which one's more? The large cube or the flat? Which one's more? Joseph?
The large cube.
Okay, so is the flat going to be smaller or bigger than the large cube?
Small.
Okay. So then how much smaller is it?
10.
If it takes 10 of these flats to make the large cube, right? 10 of the flats to make the large cube. If I only take one of them, how many of them I'm taking one out of how many? 1 out of how many total?
10.
So therefore the flat is how much compared to the large cube?
1/10.
1/10. Good, let's write that down. The flat is 1/10 of the large cube. All right, let's now take the long and compare it to the flat. How many longs did we say it takes to make the flat, Karan? 10 longs to make one flat. So if I'm going to talk about one long out of a total of 10 of them, we know that the long is how big compared to the flat? 1/10. Good. Okay, and you guys know what's coming next. Let's look at the small cube compared to the long. Haruna, how many small cubes does it take to make one long? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I take one small cube out of a total of 10 of them, we note that the small cube is how much of the long, Yanming?
1/10.
1/10 of the long. Good, write it in. You notice that when you move to the next greatest place value position, you're moving one space to the left, right? And you said it's 10 times greater than the other position, the smaller position. Good. Trishika noticed that when you move one from a greater place value to the next lesser, you're moving one space over to the right, and that is 10 times smaller, or 1/10 of the larger one. Very nice. It says you can use your understanding of place value patterns and this place value chart to write numbers that are 10 times as much or 1/10 of as much of any given number. So here we start with 300, right? 300 is 10, what number is 10 times as much as 300? What number is 10 times as much? So if I'm starting with 300 right here, and I move one space over to the left, am I getting bigger or smaller?
Bigger.
And how much bigger?
10 times.
10 times bigger. So what is 10 times of 300? What is 10 times of 300? Harshita?
3,000.
3,000. So go ahead and write that, or that question, or see where this space is right here. It says 3,000 is 10 times as much as 300. Okay. The next question is asking what number is 1/10 of 300? So if I take this same 300 and I move one space to the right, am I getting larger or smaller?
Smaller.
Smaller by how much?
By 10 times.
So what number is 1/10 of 300? Divina? 30. So 30 is 1/10 of 300. Okay, but we have to still figure out 30,000 is how much times larger than 300. So let's go. We know that this number right here is 3,000. If I move this 3,000 over one more to the left, how much is it getting bigger or smaller?
Bigger.
By how much?
10 times.
So Shreya, what's that number? What's 10 times of 3,000?
30,000.
30,000. So right here would be 30,000. So 30,000 is 10 times 10 times larger than 300. How many times larger than 300 is 30,000? Liam?
100 times.
It's 100 times.
Teachers and students.
It says use the steps below to complete the table. Step 1, write the given number in a place value chart. Step 2, use the place value chart to write a number that is 10 times as much as the given number, and then write a number that's 1/10 of the given number. So let's try if the number is 10, what number is 10 times larger than 10? What number is 10 times larger? Colin? 100. Okay, let's go ahead and write that in. All right, what number is 1/10 of 10? So if I have 10 and I take one of them, 1 out of the 10, what number do I get? What number do I get? Misaki? 1. 1 is 1/10 of 10. Very good. Okay, what about 70? What number is 10 times as much as 70? Nathan? 700. Okay. And what number is 1/10 of 70? Sorry. What number is 1/10 of 70? Claire? 7. Okay. Here comes the next one. What number is 10 times as much as 9,000? 9,000. What number is 10 times as much as 9,000? Ashi? 90,000. Yep. Hey, so since we're doing 10 times as much, how many extra zeros are we adding each time to find 10 times as much? Show me with your fingers. Because 10 has how many zeros? So to find something that's 10 times larger, we're adding how many zeros? 1. Okay. What number is 1/10 of 9,000? What number is 9/10? So here's 9,000. If I want to find the number that's 1/10, am I moving one space over to the left or one space over to the right? Okay, so if I move the 9 to here, what's my new number, Zara? 900. Good, write that in.